Hi, it's Ms. Suchi here, and today we are going to do Geometry Lesson 1.3 notes. The topic says, what's a widget? But that's just a made-up word for right now. Our objectives, though, oops, let's get a better pen here. Our objectives are to be able to write definitions and identify different types of lines and angles. So write clear definitions, identify types of lines and angles, and then angle relationships as well. So the reason why they titled this as What's a Widget is they want you to really think about how you write definitions. So for geometry, it's really important to be specific because if we say line, then we know that it's going on forever. Whereas if we say segment or line segment, we know that it has a specific start and stop. So it's really important that you describe all the characteristics of what you're trying to define. So they use these widgets, they call them, to force us to kind of give a really good definition. So here are examples of widgets. And then these ones here in red are not widgets. And we need to write a really clear definition. So if you were to try to write a definition for this, what would you write? Okay, now before I write my definition, if I'm looking at these two examples, I can see, oh, widgets are little body type things. They've got this eyeball. They've got a little claw. But over here, this is a wiggly type body thing with an eyeball and a claw. So why isn't it the same? Well, these ones have color. And so I'm looking over here at which ones are widgets. And letter B does not have an eyeball. Letter C has an eyeball and a claw, and it's got color. Letter D has no eyeball. Letter A has an eyeball and a claw. But C also has this extra shape in it, which I did not see any of those. But this one here in the non-widgets did have extra shape, so that one also doesn't work. So choice A would be the correct choice, and that's because a widget is a closed, colored figure or shape with, we could say, an arm, hand or claw, and eye. Okay, now you might have specifically wrote it differently than that, but that's okay as long as you have all the characteristics of what you're trying to define. All right, we've got more definitions coming your way here. Our first definition or term that we're going to define is counterexample. So a counterexample is something that would fit a definition, but it is not what you're trying to define. So let's say I said a square has 4 sides. Well, that is true. A square does have 4 sides, but something with 4 sides doesn't necessarily have to be a square. So this example has 4 sides, but it is definitely not a square. And so a counterexample is something that would fit what is being described, but is not what we're trying to define. Okay, here are the 3 steps for making a good definition. So we're going to use that square definition as an example again. The first thing is you want to classify. You want to say, what is it? So to be a square, it has to be a polygon, which is a fancy word for shape. The second step we want to do is to differentiate it. What makes it unique from other polygons? All right, so special things that make it unique from other polygons. It has 4 equal sides, and it has 4 right angles. All right, now test it means you gotta actually try it out and make sure there are no counter examples. So to test, we want No counter examples. Ugh, scrolly thing is not working great. So I gotta test it. So I need polygon with 4 equal sides, 4 90-degree angles. Can I call this anything else besides a square? Well, technically it is a rectangle, but a square is a more precise rectangle because it's got the 4 equal sides. So check, this looks good. All right, our next word, parallel lines. So here we have plural lines, which means more than one, and parallel means they're going in the exact same direction, but they have to be on the same flat surface or the same plane. So lines in the same plane that never cross or intersect. So if I give you an example here I have a line, and here I have a line that is parallel to it. It's going in the same direction and they are not going to crisscross. Now, in order to emphasize that they are never going to intersect, because maybe I didn't draw these super straight and they're going to start to converge at the end there if I continued on. So I want to make sure that everybody is clear in my drawing that they're not going to crisscross. So in order to do that, we do markings like we did before. These markings up here, those ones are all the same hash marks, so that means they're the same length. In order to show the same direction, we use the same number of arrows inside the figure here. So maybe I'll put in 2 arrows and 2 arrows. It's showing that they're going in the same direction, despite if my drawing isn't perfect. All right, now I'm going to name these 2 lines. So we'll call this one AB, and this one CD. And here we have line AB, the little line symbol above it. And then we have these 2 bars, and those 2 bars in a geometric sentence means parallel. So line AB is parallel to line CD. And again, those 2 vertical bars is the symbol to represent parallel. All right, continuing on. Our next term, which is on the right side of the page there, is perpendicular lines. So they're kind of the opposite of parallel. Parallel never meet, but perpendicular lines meet perfectly at a 90-degree angle. So it's kind of like the axes in a coordinate plane. All right, so I'm going to draw one of them going this way, and then one crossing this way. And in order to show that it's a 90-degree intersection, I could draw the number 90 degrees, or we can use that little corner box. And it doesn't matter which corner you put it in. You can put it in all 4 corners if you want, but that represents 90 degrees. Now, this is the symbol we use on a picture, but to show perpendicular in a sentence, this upside down T mark is what we show for the symbol for perpendicular. And it's kind of like on a protractor, the bottom of the protractor and the straight up for the 90 degrees. That's how I remember it. We're going to name these 2 so we can write that mathematical sentence. So again, I'm just going to use A, B, C, D. Makes it easy. So these are lines because I had arrows on both ends. Line AB is perpendicular to line CD. Next word, skew lines. These ones actually are a lot like parallel lines because they are lines that do not intersect. They don't cross, but they are on different planes. So they are non-coplanar. So parallel lines were on that same piece of paper going the same direction, whereas skew lines are on something maybe more 3D. So let's draw a cube here. It's a little bit off, but that's okay. And on my cube, I have lots of different flat planes. So if I'm looking at this plane on the right side of the cube, maybe I'll draw a line going this way. And then if I draw a line on the top plane of the cube, one going this way, these two planes are different, but the lines still will not crisscross each other. This green one will continue on this way, and the red one will continue on its path underneath that this way. So it looks like they crisscross on a two-dimensional sheet of paper here that I'm drawing on, but because they're in a different plane, a different three-dimensional space, one is up here and one is down here. So those are called skew lines, where they're not going to crisscross, but they're on different planes. All right, these next few words are all different types of angles, and I'm sure you've heard them or seen them before. We've actually already talked about a right angle because that was for our perpendicular lines. So to be a right angle, you need a 90-degree angle. So an angle that measures 90 degrees. An acute angle is less than that. So I make it smaller, and I'm going to put an example here, but this is not the only acute angle. So something like 30 degrees would be an acute angle. And those angles are less than 90 degrees, but they have to be bigger than 0, otherwise it would just be a ray. So an angle that measures between 0 degrees and 90 degrees. Obtuse angles are larger than right angles, but they have to be less than a straight line of 180 degrees. So I'm going to give an example here. Let's say that this is 100 degrees. So an obtuse angle is an angle that measures more than 90 degrees, but less than 180 degrees. Now these angle types are new this year. So we have complementary angles, supplementary angles. They're very closely related. Complementary angles are when you have two angles that total 90 degrees. A pair of angles whose sum is 90 degrees. Now they can be touching, but they do not have to be touching. So maybe I'll have an angle that's 50 degrees, an angle that's 40 degrees, and together they make 90 degrees. Supplementary angles also have a specific total, so we have another pair of angles, but this time their sum is 180 degrees. So if I still had that 50-degree angle here, what size angle would I need for its supplementary pair? So I would take 180 minus 50, that would have to be 130. All right, vertical angles. It's deceiving to have the word vertical because you think of up and down when you see vertical, but this is actually just a different way of, or another definition of this word. So when you have vertical angles, you actually have intersecting lines. You know, I purposely did not make a right angle here because it does not have to be a right angle. But vertical angles is when you have two angles that share a vertex, So they're both going to meet at that same intersection point, but they do not share a side. So we have a pair of angles formed by two crossing lines. They share a common vertex, which is the corner, but not a common side. So I'm going to highlight these. So I could look at maybe this angle right here in pink, and this angle right here in yellow. Now you can see that they both come together at that common corner, that vertex. But both angles have separate sides. The pink and the yellow are not overlapping each other. So maybe I'll call this angle A and I'll call this angle B. So angle A and angle B are vertical angles. Now another one that's very close to that is a linear pair of angles. And those are also made when we have crossing lines. So it's another pair of angles. But this time they share the vertex and they share a side. So if I draw that same picture, and let's highlight that same, same pink angle here. Call that angle A again. I want the angle that's going to touch, again, at that vertex, but also overlap one of these pink sides. So if I take my highlighter again, and I overlap that pink side and make an angle, this green corner now is our linear pair with A. So here they are sharing that corner, but they're also overlapping on one of the sides. Now, when they share that common side, the non-common side, this separate pink and separate green, if I look at how they're connected, they make a nice straight line. So the non-common side forms a line. Now you don't technically have to have this bottom portion. It could just be a line that's getting intersected by a ray maybe. But here we still have two separate angles. They share the corner, the vertex, and they share a side. So this is a linear pair of angles. All right, that is our lesson for today. We will complete this summary as a recap tomorrow.